Steve starts from home and rides his bike east for 30 minutes at a speed of 30 kilometers per hour. He stops for a 15-minute break, then continues east for another 15 minutes at 20 kilometers per hour, at which point his bike unfortunately breaks down. He is then forced to walk back home at a speed of 5 kilometers per hour. Draw a graph representing Steve's position as a function of time. Note that position is basically the distance measured from a fixed reference point. In this case, Steve's home can be used as the reference point. We can then treat this as a distance versus time graph. For a distance versus time graph, recall that the slope corresponds to the speed. For this question, we have to label and scale the axes, and then for each time interval, draw a line with a slope that is equal to the speed for that interval. First of all, for the independent variable, the time, and for the dependent variable, the position measured east from home. Note that since it is measured east, any positive slopes correspond to movement east, and negative slopes correspond to movement west. To scale the axes, first, the dependent variable, the position. We have to figure out the maximum distance from home. Note here that for the first 30 minutes or half an hour, he is moving at 30 kilometers per hour. During this time, he would move 15 kilometers east. During the time at which he's moving 20 kilometers per hour, for 15 minutes or 1/4 of an hour, he moves 5 kilometers east. This means that the position goes from 0 to 20 kilometers. On the grid provided, there are 12 divisions in the vertical direction. This means we can use as a scale 2 kilometers per division. For the independent variable, the time, Steve traveled 1 hour in an east direction. This corresponds to 30 minutes at 30 kilometers per hour, 15 minutes of rest, and another 15 minutes at 20 kilometers per hour. After his bike broke down, he had to walk home. During this time, he traveled 5 kilometers per hour and had to travel the full 20 kilometers. This would take 4 hours. We then have 0 to 5 hours for the independent variable. We have a total of 24 divisions along the horizontal of the grid. This means we can use 0.25 hours per division. Now to plot the graph. We start at a position of 0. This is because we're told that Steve starts from home. He rides at 30 kilometers per hour for half an hour. We draw a slope of 30 kilometers per hour. This corresponds to traveling 15 kilometers in half an hour. He then stops for 15 minutes, which is 1/4 of an hour. This corresponds to a horizontal line. He then continues at 20 kilometers per hour, also for 1/4 of an hour. During this time, he would travel 5 kilometers. At this point, his bike breaks down and he travels 5 kilometers per hour back home. In this case, the slope of the line segment will be -5. Note here that each hour he goes 5 kilometers west or backwards. Connecting these points with a line, we can see our final graph.